Section 2.4, Variables and Equations. What is an equation? An equation is a mathematical sentence with an equal sign. Here are some examples. 12 plus 8 equals 20. This is a numerical expression that is equal to a numerical expression. Another one, we have a variable expression equal to a numerical expression. And finally, we have a variable expression equal to a variable expression. From now on in this course, an equation is a mathematical sentence with an equal sign, and that equal sign divides the equation into two parts, the left side and the right side. So understand, we're going to be working on two sides of the equation to make things work for us. Here I want to state whether each equation is true, false, or an open sentence. There's two possibilities here. One, if you have an equation that has a numerical expression equal to a numerical expression, and here I have an example. Numerical expression on the left side of the equation is equal to the right side of the equation, which is another numerical expression. We have to determine if that's true or false. Then the equation is either true or false. I can actually determine that. Number two, if you have an equation with one or more variables, in other words, I have a variable expression on the left side equal to a numerical expression, that is going to be an open sentence because it could be true or not be true. It all is determined by what is the value of m. If m turns out to be the right number that matches the left side to the right side, then it would be true. But at this point, we don't know, so it's an open sentence. Here's some examples. State whether each equation is true, false, or an open sentence. Number one, on the left side of my equal sign, I have 10 minus 7, numerical expression. On the right side, another numerical expression. 10 minus 7 I can determine. I know it's 3. Is that equal to 3? And that's the question mark. And the answer here is true. Number two, numerical expression equal to a numerical expression. On the left, numerical expression. On the right, numerical expression. I can simplify both sides. Simplifying the left side, positive times a negative is a negative 14 equals, on the right side, negative times a positive is a negative 12. Now we can determine, is this true or false? This is false. And I can also represent that by a slash through the equal sign, which means not equal to. Number three, 2d minus 4 on the left side is a variable expression. On the right side of a numerical expression. I don't know if it's equal because I don't know what the value of d is. I also don't know if it's false because I don't know the value of d. Therefore, this is an open sentence. Another example, write an equation for each sentence. State whether each equation is true, false, or an open sentence. Number one, 5 times the opposite of 7 equals a negative 28. So we have 5 times 5, and times I'm going to represent with a set of parentheses. 5 times the opposite of 7. The opposite of 7 we know is a negative 7. That's from previous sections. Equals a negative 28. Since this is numerical expression on the left and numerical expression on the right side of the equation, I can determine whether it's true or false. Positive 5 times a negative 7 is a negative 35 equals a negative 28. And we know that that is false or not equal to. Number two, 12 less than 5 times the number q equals a negative 8. We have 12 less than. When we have the word than, we know we have to switch the order. This comes second. So we have 5 less than. 5 times a number q. So we have 5 times q. I can use parentheses, but I don't need to since this is a variable. That represents multiplication. Less than less means minus, and this would be 12, equals a negative 8. Here I have on the left side of my equation a variable expression, on the right side a numerical expression. I can't determine whether it's true or false, so this is an open sentence. Another example. Again, we want to write an equation for each sentence, state whether each equation is true, false, or an open sentence. Number 3, the quotient of 48 and 12 is a negative 4. Quotient means to divide, and whatever is stated first goes on top, and what's stated second goes on the bottom of my fraction. So I'm going to have the quotient of 48, numerator, and 12, denominator. Is means that we will have an equal sign. Is means equals. Equals a negative 4. And we can determine, because we have a numerical expression on the left and a numerical expression on the right, we can determine if it's true or false. 48 divided by 12 is 4. And we have a negative 4. But we know that this is not true. Therefore, this is false. Number 4, the product of 9 and a number k is 27. Product means to multiply. 9 times k. Again, we could use parentheses, but since it's a variable, we don't need to. We just pronounce that 9k, which means multiplication. Is, again, is means equals 27. On the left side of my equal sign, I have 9k, which is a variable expression. On the right side, a numerical expression. I cannot determine the truth or falseness of this situation. Therefore, this is an open sentence. Again, we want to determine if each sentence is either true, false, or an open sentence. Here we have 5 times the quantity of a negative 8 minus 7 minus 12 minus 6 equals 7 minus 9 times the quantity of 8 minus 11 minus 1. Well, let's start on the left side of our equation. We're going to work on the inside, so let's copy everything else down. 5, the bracket, the negative 8, the minus sign, the other bracket on the other side, bring down the parentheses, and the minus 6, and the equal sign. Let's just work on the left. And what we're going to have is just 7 minus 12. 7 minus 12 is a negative 5. Again, let's work on the inside out. So we're following order of operations. Bring down my 5, bring down my bracket, negative 8. And now I'm just going to do a negative and a negative. That's a double negative, which makes that a positive 5. I could simplify at that point, but I'm just going to continue from here. This is going to give me a negative 6, and of course our equal sign. Again, I want to work on the inside out, so I go inside my brackets, which is 5 times a negative 8 plus 5. Different sign, subtract, use the sign of the larger. 8 minus 5 is 3. 8 is larger than 5, it's negative, so that's a negative 3. Minus 6 equals, and then I have 5 times a negative 3, which is a negative 15, minus 6 equals, and finally a negative 21 on the left side of my equation. Let's go to the right. On the right side, I bring down my 7, minus 9, and I'm just going to work inside my parentheses first. 8 minus 11. That's really a negative 11. I'm going to either add or subtract, but since 8 is positive, 11 is negative, different sign, subtract. 11 minus 8 is 3. 11 is bigger than 8, and it's negative, so it's a negative 3. I'm going to bring down the 7, minus 9 times a negative 3. That's a negative 9 times a negative 3. 9 times 3 is 27, but a negative times a negative is a positive 27. Bring down the negative 1. 7 plus 27 is going to give me 34 minus 1. And my solution is 33. So the big question is, does a negative 21 equal 33? It does not equal. Therefore, this is a false equation. Next, I want to follow the same procedure, determine whether this is true, false, or an open sentence. Bring down the 5 on the left side of my equation. I'm going to bring down my 5. Minus, work inside my parentheses. 8 minus 3 is 5. Bring down my equal sign. I'm going to continue working on the left side of my equation. And what I'm going to have is 5 minus 5. And that, we know, is 0. On the right side, I'm going to bring down my 3. Bring down my negative 4. This is a double negative, or a negative times a negative is a positive, or a negative 1 times a negative 3 is a positive 3, equals, bring down my 3, and a negative 4 plus 3 is a negative 1, and that's going to give me, does 0 equal a negative 3? It does not equal, therefore this is a false equation. One more of the true, false, and open sentences. 9 minus 2, work on the inside out, I get a negative 2. 3 minus 5, different sign, subtract, use the sign of the larger, gives me a negative 2. Bring down the equal sign. Continue working on the left side, 9. And here I have a negative times a negative, which is a positive 4, equals 9 plus 4 is 13. And I could have started right by looking at both sides of my equations by realizing I have a variable, knowing that this is an open sentence. But in either case, I still want to simplify just to get a better look at both sides of this equation, even though I know the outcome is going to be an open sentence because of the variable. I don't know what the variable is, so I can't determine whether it's true or false. Bring down the 7, bring down the x, and bring down the minus sign. Bring down the parentheses and bracket, and all I'm going to do is a negative 12 minus 7. Negative 12 minus 7, same sign, combine, use the sign, gives me a negative 19. Bring down the 7, bring down the x, a negative and a negative is going to give me a positive 19. Or I could say a negative 1 here times a negative 19 is a positive 19. And now I have to distribute because I cannot combine these. These are not like terms. We covered that in the last section. So I need to distribute. 7 times 1 is 7x. And I have a plus sign, or a positive, times a positive is going to give me a positive. And now I have 7 times 19. And that's going to give me 133. So you can see after simplifying, I have 13 equal to 7x plus 133. This is an open sentence. And later on, we'll learn how to solve for these variables to make this a true statement. Next, we want a solution of an equation, a value for a variable that makes the equation true. Up to this point, we've been calling them open sentences. Well, here's our procedure. We're going to copy the problem from the book as we always do. We're going to substitute the given value in for the variable. We're going to simplify both expressions being on the left or right side of the equation and determine if the given value is true or false. Here's a couple examples. Is the given number a solution of the equation? My first example is a negative 12 equals 2a minus 8. I'm given a negative 2 for what I want a to be. So I'm going to substitute. I'm going to write the problem down. Negative 12 equals 2a minus 8, just like you would from the book. Write that down. I'm going to substitute in a negative 2. So I need to see this step, and then I'm going to bring down my negative 12 equals 2. And in place of a, I'm going to put a negative 2. I don't use a dot. I use parentheses to represent multiplication. Minus 8. Bring down my negative 12. This gives me a positive times a negative, which is a negative 4, minus 8. I have a negative 12 equals a negative 12 when I combine these two values. Same sign, combine, use the sign, gives me a negative 12. This is a true statement. Number 2, same procedure. I'm going to copy the problem from the book. equals 4m plus 5. And in place of m, I'm putting in a positive 2. 3, parentheses, 2. That represents multiplication, plus 7 equals, this is the left side of my equation, 4 times 2 plus 5. Now I simplify. Order of operations, 3 times 2 is 6, plus 7, and that gives me 13, equals 4 times 2 is 8, plus 5, and that gives me 13. And as you can see, this is true.